The world is Siddharth, and today is the second part of this series. Okay, this video is the second part of this series, and today's video we will be covering that how can we create some filters to match up with the pictures what we will give to as an input to our computer. So, without further ado, let's get on to this. Let's rip this. Okay, so go onto your folder or something where you have created these old stuffs right here. So CMD. So Jupyter Notebook as expected and as it is. Okay, yeah. So this was it. So where we left up is we actually synchronized our GPU with our model. So now we gotta create some filters for our image processing. And for a little correction at up, if you did fail to download some libraries of Touch Vision, I did a mistake. I typed double S, so fix that. Cool enough. So yeah, okay. So now if you run that, it will download your library. So I gotta run these all over again, and then we'll jump on to the code. So let's do this. So all the codes are working, and I just corrected that, and it says all requirements are satisfied. So yeah. So what we are going to need is another function called octave function. Now what's an octave function is, let me just type that, octave fn for short form. What octave function is, as pictures are made up of matrices, of matrix and matrices. So Octave is kind of a really powerful environment so that you can remove noises from your prepared filters. Whatever filter you will create, it will remove those noises, and we gotta remove those noises. So because it's important, because it should give you the output really precisely to the given input. So output should be precisely to the given input, means the curves of the skin and the the same way how filter works. For example, if you post some kind of picture on Instagram, you put up some black and white filter, and that filter automatically detects where your face is, and it shows a white face in the black and white filter. So that's how we are gonna make a kind of filter which can which will be noiseless, so that it will be able to recognize your edges to work with and to apply some filters on it. So we need model VGG, and model VGG is our model which we have defined it over here. So model VGG and base image. Now base image, of course, the base image on which we're gonna do our steps to convert it into a deep dream image or style transfer. This is gonna be style function. Then we need octave n equals to 6, octave nerd 6. Okay, then octave scale, we'll say set up the noise scales, smoothness scale, you can say. These are all our kind of smoothness scale what we are talking about. Iteration scale, iteration number equals to 10, and multiplied with the step arguments, args. So octaves equals to base image. I'm pretty sure. So what octave is, as the sentence says, the whatever filter is we're gonna put that onto the base image for noise reduction. And the images are stored into array. So for I in the range octaves, the number of octave equals to will be -1. Octave number will be minus to the 1. Then octaves dot append and dezoom, mp dezoom, -1. Another filter, so on the parentheses, so 1 1 1 and 0. So yeah, we have just given it some values to do some kind of mathematical to go through some mathematical procedures to actually calculate the edges and the curves on the pictures, and to zoom the filters onto the perfect points where it needs to be. So that's what we are doing. We are just writing those mathematical value which will do this. Sorry for that. So octave scale, as I said, the scale of smoothness. Actually, this thing says the scale of smoothness. Okay. So octave scale, yeah, and the order equals to 1. And once I have detail, yeah, good, detail. So detail equals to mp dot zeros, like octaves, and the comma and -1. Not 1, by the way, 11. No, just 1. So, oh yeah. So for octaves, octave dot base underscore base, the enumerate now. Enumerate means to actually collect all to take all the values and collect that into in some kind of collection or something. So that means to take out all the input data, take all the numbers or the values and make that into a collections. Maybe it can be iterable time or something, or iterable values. It depends. So after that, octaves. Then what I want to do is just copy this. So yeah, this should be not that one. Cool enough. So then I want H and W equals to octave base dot shape. I want to shape these all guys. Shape my boys. Shape these into -2. The values. What? -2. So that was for the octaves. Octaves and details. Sorry. Now we need some kind of if statement, so that if octave is greater than something, the detail will be zoomed in more deeply, so that it can catch those perfect edges and points. So let's just do that. So we can say if octave octave is greater than 0, then h1 w1 will be equals to details dot shape. Same thing what we did, we're gonna shape them, then the details will be equals to np.zoom tail. I think that will detail, not details. I am pretty sure I didn't wrote that details. Yeah, detail. Yeah, it's detail. It's detail. Okay, so parentheses, and parentheses are gonna type like 0.0 multiplied by the height of the image, and then h1 equals to 1.0. let's take that 1.0 value, yeah, 1.0 multiplied by the width of the image divided by the width 1 of the image. And the order will be equals to 1. And the source will be equals to the octave base image, whatever it we give the image as an input, as a base image on which he needs to apply some kind of filter. So source will be equals to the octave base image. So the filtered base image, the filtered image, the filters what we are creating. So that's the base. So actually that's a base. Image base is for the image on which we are experimenting, and octave base is the layer. Octave base is a kind of filter. For example, so Einstein's picture is a base image on which we are going to apply that filter, and that filter is the base filter. So we are going to call it as octave base. Octave base equals to the details. Add to the detail. Now what detail is, as I told you, we are zooming in using into the picture to remove noises, and not just detecting all the curves and cutting edges, but also to remove noises and make the filter most smoother as possible. So smooth as possible. More smoother the filter will be, more perfect it will show you a deep dream image. So yep, that was it. So for I in range, your source equals to step fn and the model vgt what we have made, model vgt. So step function. Now every neural network has some kind of step function, and if you have checked my machine learning aka artificial intelligence videos, I've talked about step functions. So over here we are taking a step function and we are doing some kind of mathematical precisions to actually give the perfect to get the perfect result on the image. Okay, so yeah, so source the variable comes from here, source, and we're gonna just multiply it step arcs. So detail equals to source dot numpy minus octave base, and I want to return the source image. So let's just run this and see if you, oh come on, line 7 for octaves. Which one? Okay, this one, yeah. Invalid syntax. Return outside a function. Okay, that's weird. That's actually weird. Is that even possible? So it must be some kind of spacing mistakes too. Okay, no errors. Nice, nice, nice. Really nice. Now we gotta make some filters. Now we are going to make some filters. Now it's my favorite part. Step. Also a model. VGG. Image. Layer index. So if you have been into image processing, or you have used ever Photoshop or software like that, some kind of image editing, so you might notice if you want to add some kind of filter or some kind of a good editing to a photo, you need to add some kind of layer, the background layer, the base layer, then the layer 1 on which you're gonna edit it. So that's what I'm making. So layer index will be the first layer on which the filter will be applied. So that was it. Then step size equals to 5, and then display equals to true. And use of learning rate equals to false, and done. So what do we need to do? So I want to say global use my GPU for this, because I don't want him to be slow, because I want to get these photos as quick as possible, as fast as possible, ASAP. So mean value equals to the np.array, storing the values into array. For the array stuff, we are using NumPy library. Then just storing that into array. Let's store those values into array. So I think I've written these values somewhere. Yeah, there you go. So I'm gonna copy this, paste that, and I'm gonna change some values over here. Cool. Okay. Now model VGG will be equal dot zero gradient so image var, image variable, will be equal to image2 variable. So we are converting image2 variable for ease, you know, for just not for ease, because we need to convert this into a tensor. Now tensor is a bunch. I told you about tensor, I think, in the last video. So what this does is actually channelize all the height, width, and height, width of the image. If it depends, because if an image ops, it will be either an individual image or separate images. So what image tensor does is it channelize all the images according to the height and width. So and tensor only takes as variables. So we need to convert the images, the matrix values, into a variable, and it will be easier for us to feed that as a tensor. So that's where Torch comes into play. Torch dot tensor. So image requires, what it requires is is grade. Where's the grade? True. Goes to CUDA. Use the CUDA. Use so what Python does is, if you want to use GPU in Python, you need to have CUDA installed on your computer. So that's what I'm doing over here. So I want to optimize it. Optimizer equals to SGD. This comes from the module what we have installed. Module what we have installed. Yeah, I'm saying the right thing. Var equals to iterations equals to step. Yeah, var comma and step size. How much steps are you gonna take? And so weight about the decay equals to 1e4. What happened? Oh yeah, 1e4. What? 1e then minus 4. So what it is, it's just learning rate. It's just a learning rate at which our module needs to be trained on. So that's the learning rate. So and learning rate is actually means to decrease the cost function of the iteration, and iteration is to loop some kind of process again and again. That's what iteration means. So whatever the input is gonna be, it will be, so whatever the output will be, it will be taken as input. So that's a loop. Okay, so that's a loop. So how many times it's going through the network, that's a looping part, and you need to decrease that for better results, for more accuracy, So equals to image var, so for index layer in enumerate model VGG dot features. So x equals to layer x, and if index and layer and enumerator enumerate. So what do I want to do? I think that's wrong line. Yeah, that's wrong line. So equals to layer index, and then break the function. Then I want something like output equals to output equals to x multiplied by the array of 0 filter index and loss will be equals to the output dot norm. So yeah, that's it. So and the loss will be dot backward. So we are done over here. So at the very bottom. So at first we are giving the cell to actually filter to use my GPU. Then the mean value, we are setting up the mean value into an array, and then we are reshaping it. Same goes for standard. Then we are using model VGG dot zero grade function to actually to remove gradient from the filters. The image var, we are converting image to a variable for tenses, and we are using optimizing function to increase the iteration step, to decrease the iteration step using the learning rate from the module what we have downloaded, the model what we have downloaded, model VGG, the pre-trained model. So yeah, let's jump to another thing. If use L2, what the hell am I writing? No. So if use L2, then I will say, so L2 is nothing to just normalizing the gradients, not just to remove the gradients. I am applying the gradients, I'm not removing the gradients, I am applying. But let me show you the image what I did. So 3D print pixel, let's pick any of them. So what you see over here is you see green, red, and the stuffs over here, those are gradients. The dark side and the white side, those are gradients. And we are doing it, we are just normalizing those gradients over here. We're gonna normalize the gradients over here. So that what it says, model.vgg to 0 grade, that means the same. So yeah. So let's type it. Mean square. The mean square equals to torch dot tensor equals to the torch mean value dot mean then image var dot grade dot data. I'll multiply that to then, so 1e minus 5, the learning rate, if you want to, if the filter uses my GPU, then what I want to say him to do is mean square will be equal to mean square will be equal to the mean square dot CUDA. So whatever he's gonna take, his value is from the CUDA from my GPU dot CUDA, and image var. So image var dot grade dot data will be torch dot squirt, QRT, that's how I pronounce it. So squirt means is to square the root values what you have. So mean square values, whatever the input matrix value is, it's gonna square them to actually fit those gradients onto the image, and we're just squaring those older values using the torch library. And then the next thing comes up is the mean value of the square values. Mean, also that's the same. So then just copy this, paste this, and over here we just got change image var dot grade dot data multiplied by the step size. else? Okay, so else I want optimizer to. So what does optimizer means is to compress the image into a PNG or JPEG format. So that what optimizer means over here. So optimize steps and the result. What's the problem with you, man? Result equals to the image var data yeah, dot CPU, because I also want him to do the mathematical calculation with CPU too, to make it more faster and more accurate, according to me. So image var dot data dot CPU is to actually you can say to. Okay, so what does CPU do is it just calculates the data what is being output. So that's the same what we are doing. We want our CPU to calculate these output produced by our model. So yeah. So got too much to write. Dot numpy. I mean, it's sweaty around here. Numpy, then image for then result. I will say result. Then yeah, equals to np dot clip np dot what the result and that will be equal to 0 times this times this times this. Come on. We minus the mean value and std minus the mean, the standard std, and the thing. Okay, so maybe a few more things to write and then we're done. So let me just type this out really quick. If display does show tensor oopsie doopsie, show tensor will be equals to the result. So all the tensor whatever matrix has been calculated, store those things into result and show me that as an output. So gonna return this. So return torch dot tensor and the result. So what we want to return is the result. So last definition to write, visualize filter while VGG the base image, the layer, index, basically. So let me just write these all variables out first, and I'll catch you back later, or just type it with me, because I just gotta explain as I go. So filter index, first filtering layer, we index, then number of octaves will be 6. Octave scale equals to 1.4, and the iteration step number of iterations equals to 10. So go through my model for 10 times. Come on. Got cold, man. So yeah, let's make some space. And then step size. We'll need some light, so step size will be equal to 5. Let's take it 5. And display equals to, display equals to true. And use of 2 will be equals to false. That's it for now. So yeah, now I want to return. This is the last part of a cell. Don't worry, it's gonna end. Octave, number of functions. So model G and G, I think it's gonna take the same thing. What we did, okay, except if not just calculating it, we just can't write that. So okay, let's just copy this first. Copy this and let's see if everything goes right or wrong. Well, let me just type all the values because it will be turning is all the same what we did last time. Maybe these much of codes. Once I write that, I'll catch up with you. Okay, let me just show you each step by step, or else it will be kind of confusing for you all guys. So octave n is equal to octave n2. So octave n equals to octave n. So and octave scale will be equals to the octave scale. Iteration number of iteration equals to the number of iterations. And so and layer index equals to layer index. Index, so and at last I want to say filter index equals to filter index. Step size. Okay, so what we are doing, whatever the value comes into the octave function, we just want to return those we just want to make it as default values. Whatever the values comes out, we want it to be a default values. That's G. Now that's what I call a freestyle, man. So display equals, come on man, display equals display. So display equals display and use of L2 equals to use L2. So much. Let's just run this and see. Come on. Line 1. What's D with line 1? Steps. Okay, I didn't define the number of steps. How it can't be without an indentation error. Cool. Great. Where is it, by the way? Def up square. Mean squared. Partial tensor mean square. Mean square. Mean square. So what does it say in the unexpected indentions? Else invalid syntax. What's wrong with syntax, man? I didn't get that. What's wrong with you? Maybe due to space, must be. Else. And this GPU part. Else, okay. So let's see if this is right or not. I don't understand what the problem is. I think over here maybe yeah, think so. Image or squirt, image raw data, and let's make that up and make that 2, and let's do like dot add the image, then delete all these stuffs. Still we have else problem. So let me just copy and paste what I did the last time, and let's see if it makes something. Okay, so I just copy pasted that that line. It was about the spaces. So now what the next word is result. Copy this, paste that onto find thing. Okay, and what this says is unexpected indent. So pretty sensitive, man. What's the matter? I got it. I really hate these spacing stuffs. There's a display. Yep. It does not match. 939. Says and return should be like here or something outside of the function. Okay, no errors. Cool. Pretty good. Very good. Last parameters. We want to show up these layers. Oh sorry. What I'm typing. Layers. So number of layers. We want number of layers. Then we want filters of iteration. Iter equals to 10. Then we want filter endings. Filter end equals to 20. Then once step, so a number of step size equals to 7. Then we want to use the learning rate for this. Use L2 equals to. We don't want to use false. We don't want to use these learning rates for this right now. Filters equals to and titles to is an image np equals to initiate the image size equals to 600 into 600. Then for I in range, say for I in range, filter start filtering it, filter till the end. Say it's a title, layer, let me just type this quick. I gotta catch up my dinner, so let me just type this really quick. Dot format. So let me just write these, and maybe in my next video I'll explain every single line of code, because the next video is gonna be long enough to tire you all guys. Print title visualize the filter. Come on, visualize filter. Why filter the model? So I just copied that, and yeah, now it's good. So it was about the you can say the wordings error. So yeah, so just one line of code, and we are done, guys. We are done. Just one line of code. So we have prepared our filters. Now we need is images and titles. So titles equals to show the layers. Show layer to 1 equals to use the gradients. Use the gradients equals to true, and equals step size equals to 0.5, 0.05. Let's just run this. All fingers crossed. Love Eminem. INIT image not defined. Okay. So error has occurred because I restarted my notebook, so I need to rerun this. So rerun all of these things. Let's come. It's recording. So still INIT image not defined. Okay, so why is that? Oh no. Something is wrong. Something is wrong. What the heck is wrong? I don't know. Okay, so in the upper section it was INT, so it should be initiate. So now it's gonna work. To me. Now I hope it works. Okay, and come on, man. Let's copy this. Copy this. Where is PIL is not defined. It has no image attributes. Where is it? Where is it? Where is it? $65. Oh, 65. Why is that so then? Okay, so spelling mistake. It should be I. Should be I. Yeah. Should be out of errors. Now it's gonna work. Oh, come on, man. Images. So I think I gotta end up the video. It's too long. There will be a video. I just need to catch up my dinner, and then I will make another video about the error fix. Okay. So for now, bye. Thank you for watching my videos. Please subscribe. Comment me if you have any questions about the related content of this topic. If you have some kind of confusion, just let me know. And just download my game. It's in the link of the description, and subscribe my channel. Thank you for watching. Have a good day. Happy flying. Happy programming. Good night. I'll catch up with you back again. Bye.